So here we're multiplying and dividing. So very similar to simplifying. So basically here, we want to just multiply straight across, right? But before I multiply, remember, it's probably better to know, I want to know what the common factors are. So instead of multiplying together and getting, a bigger polynomial, it's better if I factor first. Just like with smaller numbers, it's easier to identify factors, the same with polynomials. So what I'm going to do is I'm going to try to factor all the numerators and denominators, factor as much as I can, and then see what those common factors are and see if I can reduce from there, and then I'll multiply. Okay. And so x minus 5, that's completely factored, right? Where that's a prime polynomial. I can't factor anything besides a 1 out of that, right? It's not a difference of squares. It's not a difference of cubes. Nothing we can do with that. So here, 25x squared minus 1, that's a difference of squares, right? So the square root of 25x squared, that's a perfect square. Square root is 5x. The square root of 1 is 1. And since it's a difference, we can do all this. And so then I'm going to put a plus here and a minus here, right? So I'm going to start collecting, or actually, if you can do it either way. If you want to start collecting things down here, you can. I've also done it before where, once I factor, then I kind of cross these out, and then I can just cross cancel right there. So if you want to save yourself writing this step, you can do it there. Just kind of make sure you keep everything, keep everything straight. All right, now let's take a look at this one here, 10x minus 2. So that's not a difference of squares, not a difference of cubes, not a sum of cubes. It's a binomial. But so the only thing we can do with that is actually GCF. So we do have a GCF there, which is 2. 2 goes into 10 and 2. So I'm going to factor out a 2. And so then I'll end up with 5x minus 1, right? So I put a 2 on the outside, and then a 5x minus 1 goes back inside. All right, then I'm going to put these over here, 5x plus 1, 5x minus 1. We may have already found a match, right? And then on the bottom here, this is a simple quadratic. So the way we deal with those is we just put an x here and an x here. We find numbers we can multiply to get 25, that we can add to get 10, or numbers that have a product of 25 and a sum of 10. Signs are the same. So 5 plus 5 is 10. Remember, this is the sign of the bigger number. So they're both going to be negative because the signs are the same. So we get x minus 5, x minus 5. So this is actually a perfect square trinomial. So we could write it as x minus 5 squared. But I'm just going to write it as separate just because it's easier to kind of cancel and see what happens. All right, so now it's just a matching problem right now, right? After you factor, now it's just a matching problem. This matches with this. Anything on top that matches with anything on the bottom, you can reduce, right? Same with this and this, okay? And that's it. That's all that can match, right? Even though this has a 5 and this has a 5, those are parts of a package deal, right? So I can't do it without canceling everything out. Same with the x's. All right, so all I have left on top is just, remember, there's invisible 1. When you cancel something out, it turns into 1. So 1 times 5x plus 1 is just 5x plus 1 on top. And on the bottom, I have 2 times x minus 5. So 2x minus 5. And that's it. If you want, you can distribute the 2, so this is okay as well. If you want to get 2x minus 10, that's totally fine. But this is acceptable to leave it in, factored. Okay. All right. Now remember, if you wanted to, you could kind of do it from here. That would be fine. If you wanted to keep it, without having to rewrite everything, you can just kind of just remember that once you factor something out, those are gone away, and you're just dealing with the factored form. All right, now number 4, very similar, but we have a division situation going on. Same idea though. All we're going to do is we're going to flip this over and multiply, right? So like I can see the s plus 4 I cannot factor, so I'm just going to put that on top. I can factor this numerator. It's a simple quadratic, or at least it looks like we can factor it, right? It's actually the same as what we saw here, but s's instead of x's, so it's going to be s minus 5, right? Numbers that have a product of 25 and a sum of 10. signs being the same. So both negative. So -5 plus -5 is -10. If I multiply those together, I get 25. So I'm going to put these down here. S minus 5. S's and 5s are never good to have together, right? They look similar, especially depending on how your handwriting is. All right, so then we're going to keep this one in the same order. So the denominator is already factored. S plus 4. These don't have any common factors bigger than 1. And it's squared, so it's actually already in factored form. Then the numerator, here we have a complex quadratic, right? So because there's no common factor and we're left with a 2, a number bigger than 1 in the leading coefficient, right? The A term. So we're going to multiply 2 times 15, and that gets us 30. So what numbers we can multiply to get 30 are numbers that have a product of 30 and a sum of 7, where the signs are different, right? So it's funny, last time we ended up with 2 and 15. We started with 3 and 10. This time, 3 and 10 is what we need, right? Because if the bigger number is negative, that means 10 needs to be negative. The signs are different, so that means the 3 needs to be positive, right? And positive 3 plus -10 is -7. So we found our numbers. So now we can put them in here, v plus 3 and v minus 10, but we have to divide by a. So it's going to be, oops, I meant to use the red here. So 3 over 2, 10 over 2. So this reduces to 5. So it's just going to be v minus 5. I'll put it down here. And then this one didn't reduce, so the 2 is going to come to the front. So it'll be 2v plus 3. All right, so now we can just see what matches, right? It's just a matching problem. So v minus, oh, I'm sorry, I don't know why I put v's. It should have been s. Sorry about that. So those should be s's there. So I see that s minus 5 matches up with s minus 5, right? And I don't know why I did that one. I could have done that one, right? Either way. Okay. All right, and then since we have 2 of these down here and only one of them on top, we can use our exponent properties to subtract 2 minus 1 is 1. So basically that turns into a 1, right? Or you can think of it as cross out one of these and one of these, so you have 1 left over. All right. And then I don't see anything else that matches up exactly, and it needs to match up exactly. So I have 2s plus 3 is the only thing left on top after all the dust settles. And on the bottom, I have a s plus 4 to the first power times s minus 5. And that's it. Okay. Once again, if you want to FOIL this, you can, but it's just a little more work, and it also could potentially set up an error. So I would just recommend leaving it the way it is. All right, so that's how we multiply and divide. So basically the same thing. The only difference is we have this step with dividing where we flip that guy and multiply. But both ways, what we're going to do is we're going to factor, and then we're going to try to reduce by canceling anything on the top that matches anything on the bottom. Or in other words, common factors.